All right. So we are continuing to go through the 2008 FRQs. I'm going to
Mm-hmm.
do Q4, and then we'll do 5 and 6, just like last time.
Mm-hmm.
So we're doing particle motion, where the goal is just to relate different parts of particle motion, both graphically and analytically. So I've got a chart here listing a bunch of our scalar values and vector values for particle motion. Scalars without direction, vectors with direction. So if I had, for instance, a change in people in the cafeteria, so that's a rate of change in the number of people. I could drive down to get the acceleration of people in the cafeteria, so that's how fast the rate of change in people in the cafeteria is changing. Or my second derivative of people entering the cafeteria or leaving the cafeteria. So that would be people entering and then people leaving, and the change in those rates. If I just wanted the rate of change, that would be the rate people entered minus the rate people left, or dp over dt. If I wanted the total number of people, then I could integrate that rate. So I'd start with my constant, which is the starting number of people, and then integrate from T1 to T2. Both the people entering and the people leaving. So when you integrate those rates, you get an amount. Any questions on particle motion?
Nope.
Okay, so I'm going to give it a shot. So we've got this particle that's moving along the x-axis, so that its velocity at any time t from 0 to 6 is given by this differentiable function shown above. The velocity did cut off the y-axis here, but this y-axis is velocity. Okay, so our velocity is 0 at t equals 0, 3 and 5. And the graph has horizontal tangents at 1 and 4.
Mm-hmm.
The area is bounded by the t-axis and the graph of v on the intervals 0, 3, 3, 5, and 5, 6 are 8, 3, and 2 respectively. So 8, 3, 2. At t equals 0, the particle is at x equals negative 2. Okay, for my interval from 0 to 6, I want to find both the time and the position of the particle when the particle is furthest to the left, and then justify your answer. What do I have to do?
So farthest to the left means going to no, I mean speeding up in negative direction.
Okay,
So which is 3 because at 3 it has full negative area. But I don't know how to explain it. It should be 3, I think.
okay, so you're right, this should be 3. So our velocity can help us understand which direction we're going to.
Mm-hmm.
Um, so our velocity from 0 to 3 is negative.
Mm-hmm.
Um, our velocity from 5 to 6 is positive. From 3 to 5 is positive, and from 5 to 6 is negative again. However, we can see with the areas that our integral from 0 to 3 is going to bring us down by 8 units. We'll only come back by 3 and then go to the left again by 2. So we should be the furthest to the left from our start point.
Mm-hmm.
Once we've finished going as left as we possibly can. So let's get our points maybe. So if I wanted to solve for x at 3.
That's negative 8.
Not negative 8 actually.
Eight?
Nope.
Oh wait, oh, negative 10.
10. Okay,
Because,
so that
yeah,
was
start with minus 2.
okay, minus 2 plus our integral from 0 to 3 of our velocity
Mm-hmm.
is negative 10. I'll grab x at 6 and x is 0 as part of my proof too. Um, I'm going to do x at 5, 6, and 0 maybe. X at 0 was given as negative 2.
Mm-hmm.
What's x at 5?
Minus 2 plus integration from 0 to 3 plus integration from 5 to 3 to 5. So that's negative 5 minus 2. So, no, I mean, yeah, negative 5 minus 2. So that's negative 7. And yeah, so that's negative 9.
Okay. So then we could write our conclusion somewhere over here. So our velocity is only negative on 0 to 3 and 5 to 6. So let's say v of t is less than 0 on our intervals. 0, 3, and 5, 6. And positive on 3, 5.
Mm-hmm.
As the function is continuous and right position. As the position, because I've got more than one function going on here, it's continuous and monotonic. That just means moving in the same direction on those intervals.
Mm-hmm.
The furthest leftmost. The leftmost position is at t equals 3. Okay, something like that.
Mm-hmm.
Okay. Then I want to know how many values of t on 0 to 6 is the particle equal to negative 8?
So, we start from negative 10, negative 2, and then we're going to negative 10. So at some point there should be 1 and negative 5 is 9.
Okay, so
We
this
have
is
3 times.
okay. So there are at least 3 values.
Mm-hmm.
where the particle is at x equals -8, as which theorem is going to prove it, and what has to be true to use that theorem?
Mean value.
Mean value deals with slope.
Intermediate.
Okay. Intermediate value. What does the intermediate value theorem tell us?
So, if the function is continuous in interval a and b, then between a and b, the function has all the y value.
Okay, I'm going to reword that just a little bit, but the intermediate value theorem guarantees that a continuous function will pass through all y values between 2 points. And we know that at some time on these intervals, 0, 3, 3, 5, and 5, 6. Okay, any questions on what we did?
Nope.
Cool. Okay, for part C, I want to know which of these intervals is the speed of the particle increasing or decreasing, and give a reason for your answer.
Speed at t at 203. Increasing because speed does not have direction.
While you're right that speed doesn't have direction, we can still figure out whether the speed is going to increase or decrease. If you, okay, I'm going to say this is you. And I'm going to give you a jetpack. So you've got your jetpack and you're moving to the right. And you realize that there is a wall coming up. So as you're moving to the right and you don't want to hit the wall, you turn yourself around and start to jetpack the other way, right? Okay. Are you going to be speeding up or slowing down?
Slowing down.
Slowing down, because your velocity right now is going to the right. But what's happening to your acceleration now?
Acceleration decreases.
Acceleration...
Oh, increases, but velocity decreases.
Okay, your acceleration is going to the left. Because your acceleration and your velocity are fighting each other, you will be slowing down. Okay. If you hit a point where your speed equals 0, and you start to thrust away from the wall. So now your velocity is also moving to the left. Now you'll be speeding up because your velocity and your acceleration are acting in the same direction. So the key to speed is if velocity and acceleration are acting together, so same direction, then your speed is increasing. If they're acting against each other, then your speed is decreasing.
Mm-hmm.
Okay, I'm gonna do one more. If you throw a ball up, you have a lot of initial velocity where the ball is going up. So on your arc, from the point where you throw until your maximum height, the ball is slowing down. So your vertical velocity is positive, but your acceleration, in this case due to gravity, is negative. Okay, after you hit the maximum height, your ball starts coming down. Your vertical velocity is negative, and your acceleration due to gravity is still negative. So on this side, your ball is speeding up, and on this side, your ball is slowing down.
Mm-hmm.
Okay, so let's try it with this question we've got here. I want to know, on the interval from t equals 2 to t equals 3, is the speed of our particle going to increase or decrease?
Two and three between.
Yep.
Increase.
Is my velocity positive or negative?
Negative.
On 2 to 3, v of x is negative. What about my acceleration?
Positive.
V prime at t is positive. They're fighting each other. So
Mm-hmm.
is this particle speeding up or slowing down?
Slowing down.
Slowing down. So the speed is increasing or decreasing?
Decreasing.
Okay. So therefore the speed is decreasing. Speed is decreasing. On that interval. As Vx is negative and V prime x is positive. Okay, I kind of answered that one for you, so I'm going to ask you another one. Can you give me another interval where the speed would be decreasing?
Speed decreasing. 4 and 5.
Okay, 4 and 5. So on 4 and 5, velocity is positive, acceleration is negative.
Yes.
Okay. On the interval from 0 to 1, is the speed increasing or decreasing?
Increasing.
Increasing. Why?
Because slope is negative and velocity negative.
Okay, so slope of velocity is acceleration, so acceleration is negative and velocity is negative, means that your speed will be increasing.
Mm-hmm.
Okay, cool. Last one. No, during which intervals, if any, is the acceleration of the particle negative?
So slope is negative. So at 0 to 1 and 4 to 6.
Okay, you gave me the reason, but if I wanted to write this out mathematically, what could I say?
V prime t is equal to a, maybe, and a is negative between that interval.
Yep, looks good. Okay, so I'm gonna throw up the scoring guide really quick. Okay, identified T is 3 as a candidate, considers the integrals, and have our conclusion. We were furthest left at -10. Okay, we look good. Um, used positions at 3, 5, and 6 with a description of motion and a conclusion. Okay, we did the description of the motion. Conclusion. Intermediate value theorem, we had 3 values. Okay, we did that. Did we consider position at 3, 5, and 6? I believe we did, but I don't remember. Yes, 3, 5, and 6. 3, 5, 6. Okay. So I'm going to give us that. Speed was decreasing on 2, 3, since velocity was negative but increasing. Okay. And then acceleration is negative as velocity is decreasing. Okay, cool. So that's 9 out of 9 points. Any questions on anything from today?
No.
Okay, again, thank you very much for coming. I'll see you same time tomorrow for physics.